Alright, modeling steel joists. Steel joists are a specific type of the member of the United States. They are constrained with the standard type specified by the U.S. Steel Joist Institute. They are standardized in terms of span, depth, and load carrying capacity. Steel joists or bar joists are simply supported secondary members which do not support any other member, only supported load areas. Steel joists can be defined at any of the differing levels. They cannot support any other member. Slab and roof loads are supported by steel joist. Loads are distributed to them. How to specify a joint type and size? Specify the model of the type of joist. Click model steel joist in section box. Cut new and edit. Pick the shape for the size required for the section dialog box and click select. Before proceeding to create the joist, check for the remaining steel joist property set and the property windows adjust as required. How to create a steel joist? Select the joist type and size. Click where the joist is start point 1. If you're using a point along the member, click for the member first to see the points. Click enter the one you for the type of the distance of the point with the start of the member. 3. Click where the joist is the end point 2. How do I modify the position of the steel joist? You can modify the joist position with the model both in 2D and 3D views. Select the joist to be moved. The joist is highlighted in one color. The joist ends nodes in another. The new selection, select the end node to be moved and ensure the node is highlighted in the select NE tooltip when selecting open opposed to one of the members connecting to the node. Click the greater construction point to redefine the joist end node position. The joist is redrawn spanning the new end position. Modeling steel trusses. Trusses are particularly arrangement of the member of the Tekla structural design calculate automatically for you. Once you've created a structure that you can copy throughout with your model necessary, you can pick a truss and move it into the location you require. Once you define and loaded your truss, the Tekla structural design automatically changes the member side of the specified to determine their adequacy. How to use steel truss wizard? Model steel truss. Choose the truss shape with a list of the standard truss patterns. Click the truss start point. If you're using a point along the member, click the member first to see the points at either point we want to use. Type the distance for the point with the curve of the member. Click the truss endpoint, click next. Specify the truss alignment parameters, click next. Then specify the truss details, click finish. How to use a space truss wizard. Click model steel truss drop down list. Click select space for the drop list. Choose the interlinear plane of your truss type to specify the alignment and the number of bays, then click next. In the 2D 3D view, the truss location points. Linear truss can click start and end points. Plane of your truss, click the 4 corners. Specify the height, then click next. Define either straight or curved truss geometry, then click finish. Specify the truss alignment parameters, then click next. Specify the truss details, then click finish. How do I find the freeform truss? Freeform truss can be created by placing a series of the truss members in the shape required. Now open a 2D frame required for the trusses to be created. Note that the freeform trusses can be created with a 3D view and 2D level view. Pick model steel truss drop down list. Select freeform with the drop list. Click the first truss member is to be start. Click where the first truss member is to end. Continue the same way to paste each truss member until the truss geometry is complete. Press escape to finish. How do I edit the geometry existing steel truss? Hover the cursor over the truss to be edited when it becomes highlighted. Right click, select edit from the drop down menu. The truss wizard is displayed. Edit the properties as required, then click OK. How do I edit sections of the size and material grade section orientations in the existing steel truss? Hover the cursor over the truss to be edited to become highlighted. Left click with the truss display with the edit truss property set. Review for the properties just necessary, then click OK. Modeling portable frames. How do I create a single span portable frame? Click model portable frame, grid point with the first column base, then click select X and Y coordinates or origin from the frame. Click the grid point for the second column base, and define with a positive local X axis during erection of your frame. Second grid point must lie with the same construction level as the first grid point. Portal frame dialog is displayed only when specifying the geometry and section property details for all elements within the frame. Initially, the local coordinates of the left hand and right hand eaves are invalid, and as denoted by the red crosses, this because of the eaves heights has been yet to be defined. Click edit to specify the eaves level to choose the frame type of the required and complete with the frame geometry from the first span. Once the span geometry has been defined, click OK, return to the portal frame dialog box. Click rafters to review the rafter section size. Click columns to review the column section size. Click haunches to specify any haunches. Click base to specify the base fixity, either pin or fixed in necessary adjustment base levels. Nominally pinned and nominally fixed bases can be specified, but only with the editing individual support property to the property windows after closing portable frame dialog. When partially fixed bases have been defined with a fixed type is the subsequent display of the user portable frame dialog. See partial fixity of the column bases. If you're required to click other pages of the portal frame dialog box in order to specify whether you're required any of the valley, ties, tie members, part bits, or part bit members. The horizontal vertical rotational stiffness that can be defined with the valleys page of the valley beam support are only ever used on the frame is exported with the portable frame design program elastic plastic analysis and design. Because the frame is exported in 2D, the valley beam, which is out of plane, is replaced with single spring support with a stiffness and Tekla structural designer. There's no spring support at the valley, and these stiffnesses have no effect on the analysis or design. 11. Click the span to add the extra spans into the frame. How do I create a multiple span portal frame? Start defining a single span frame, then from the spans page portal frame dialog box bottoms to use the buttons to introduce extra spans as required. Click add to introduce a new span to end of the frame. Click insert to insert a new span below the currently highlighted span. Click copy to copy currently highlighted span to a target span. This is only can be used to replace pre-existing spans with a copied span. It does not insert a new span. Click mirror to mirror the currently highlighted span to a target span. This can only be used to replace pre-existing spans with a mirrored span. It does not insert a new span. How do I edit properties with the existing portal frame to edit with the overall frame properties? However, the cursor over the portable frame of the edited to become highlighted. Right click and select edit from the context menu of the portable frame is displayed. 3. Edit the properties as required, then click OK to edit the property individual port frame member. However, the cursor over the portable frame member to be edited, use the drop-down arrow key, select the objects listed and select any tooltip when the individual portable frame members have become highlighted opposed to the entire portable frame. Right-click, select the option to edit the individual member from the context menu. The property dialog box for the member is displayed. 4. Edit the properties as required, then click OK. Modeling cold rolled sections. The following characteristic type of the cold rolled sections can be specified in the Tekla structural designer: track, stud, joist, purlin, rail, eaves, and beams. Cold rolled sections can be modeled and analyzed in Tekla structural design, but they are not designed. How do I create a single cold roll section model steel beam? Any other elements types that it does not actually matter which. Change the characters for the property set with the type of the cold roll sections you require. Property display to update appropriate chosen cold rolled section type. Review the cold roll properties or adjust as necessary. Click 4. Click where the members start point 1. If you're using a point along a member, click the member first to see that the points. Either click the point you want to use or type the distance of the point for the start of the member. 5. Click where the member is to end at point 2. How do I modify the position of the cold roll section? Modify the cold roll section both in 2D and 3D views. Click the section you want to modify. You'll see 2 handles at its end. And move to the end of the section you will handle it. Move it to the new location with the mouse. When the end is where you want it to click again, fix it to the end of that point. Modeling web openings. Although web openings can be added to steel beams and columns, they are only considered design composite, non-composite beams designed either in Euro codes, BS codes, and AISCs. Web openings can be either be quick layout process or manually. Quick layout creates web openings of maximum depth space to the minimum center's recommended section size, which also maintain a certain geometric proximity recommendations. Web openings can be defined manually in 2 ways. Web openings dialog page, quick layout, clear it out, add buttons to add a new line. Web openings grid to allow the geometric property web opening to be defined. Alternatively used for the add buttons to open a web opening detail page dialog box, which give the access to more help. Comes to defining the opening, both methods give the warning and invalid text for data entry checks with the provided assistance for the opening parameters is defined on web opening details dialog page. The turn button and position of the opening of the beam center, while its auto button will position the opening to meet the spacing recommendations. Also, the page tool gives the information for the recommended values for opening parameters. As web openings are defined, they are immediately visible in the diagram of the web openings dialog box. The diagram displays with the result of the geometric proximity checks that are carried out with the opening parameters. using a warning invalid display colors to highlight those areas that are outside of the recommended limits. The areas are subjective to the check the endpoints of the web post, web opening, dimensions, and T dimensions. The displays helps you to decide whether to make any adjustments to the opening of the parameters before the design is checked. You should bear in mind that checks are carried out with the stage of the geometric checks only, and compliance with recommended limits but does not guarantee that the opening will pass for the subsequent engineering design checks. Related topic: web openings AISC, web openings SCI P355, web openings SC P068. How do I add a web opening to a quick layout? Using quick layout, the method enables to create maximum depth opening space at a minimum center's appropriate section size. However, the cursor over the member in which we want to add web openings so that they becomes highlighted. Right click and select edit from the drop down menu. Ensure automatic design is in the preset in the properties is cleared. Web openings cannot be added to members that are in auto design mode. Click Web Openings page of the property dialog box. Select Quick Layout. So select whether you want to start setting out the Viva label openings from the drop-down list. So for the type square, rectangular, circle, the type drop-down list, data of the first web opening automatically created as file. The length of the opening, rectangular opening is only. Depth of the opening, distance of the set out point of the center of the opening, letter distance of the end of the one member of the center of the opening, distance from the top of the member of the center of the opening, and relative to the indicated setting out points for the LCR is measure of the defaults for your label opening forms openings from the drop-down list. And R is related to field only as applies is true to the opening option from the LCR relative to the drop-down list. Specify the existing opening number that you want to use setting out point of the new openings. So we have a square and a circle. So if stiffness is required, select the location stiffening drop list. Data of the stiffeners are entered manually as follows. You may need to widen the dialog page to see relevant column headings. DS, depth of stiffener. TS, thickness of the stiffener. L, length of the stiffener. ES, distance of the edge of the opening of the center of the stiffener. It shows a beam. Click Add to select the type of the drop list to create further openings from the chosen setting out point is required. At this point, label openings from the drop list. Switch to the new setting out with the next opening. How do I add web openings manual? Web openings AISC, web openings SCP355, web openings SCI P068. How do I add web openings manually? The method enables you to create openings of specified depth and spacing. However, the cursor over the member, if you want to add web openings so that it becomes highlighted, right-click and select Edit for the drop-down menu. Ensure that automatic design and property is cleared. Web openings cannot be added to the members that are in auto design mode. Web openings page property dialog box. Ensure quick layout checkbox is cleared. Select whether you want to start setting out label openings from drop-down list. Click Add as opposed to Add. Select type, square, rectangular, circle from the type drop-down list. Manual specify the dimension of the web opening. LO, length of the opening, rectangular openings only. DO, depth of the opening. And then manual specify the distance setting out with a point from the web opening. LCR, relative to the indicate setting with the point with the LCR is measured for the defaults for the selection of label opening from the drop-down list. NR is relative to the field only apply to the chosen opening option from the LCR relative to the drop-down list and specify the existing opening number that you want to use setting out with the point for the new opening. LCR, the distance of the setting out with the point of the center for the opening. LC with the distance from N1 over the member to the center of the opening. Click Add for the LCR, and LC automatically calculated as the minimum values appropriate to the size of the opening. Your DC is the distance of the top member for the center of the opening. Click Center for DC to automatically calculate the position of the opening centrally in the section depth. 11 stiffen required stiffen end box. Create a second page on the dialog box. Select the location stiffening drop list. Data from the stiffeners are as follows. DS, depth of the stiffener, thickness of the stiffener, and length of the stiffener, in the distance of the edge of the opening of the center from the stiffener. And then click OK to create the opening. 13, create further openings either by clicking Copy to create multiple copies selected opening, or click Add to create a single opening in a different size or spacing. How related, how do I add openings quick layout? Web openings AISC, web openings SCI P355, web openings SCI P068. Compound sections. Comprehensive lists of predefined compound section types are available in Tekla Structural Designer, include many of the common arrangements such as rolled eye sections with plates to the bottom top for both flanges, rolled channels, toe-to-toe, back-to-back, with or without plates, rolled angles and steel joists, and star arrangement. Okay, so we'll look at the list. So it shows eye-plated beams, plated columns, rolled section bottom plate, rolled one section with plate, rolled one section top plate, rolled steel joists with plates, plated one section with plates, star section in the plates, double rolled eye sections, double rolled eye sections with plates, welded sections with plates, rolled angles and star arrangement, rolled channels toe-to-toe, rolled channels toe-to-toe with horizontal plates, rolled channels toe-to-toe with vertical plates, rolled channels back-to-back, rolled channels back-to-back with plates, bullet box with plates, rolled steel joints and star arrangement, and rolled steel joints, plates, or star arrangement. You add user-defined section database each compound section type as when required. Once you have the defined compound sections are available for all models. Compound sections can only be applied with steel beams and steel columns. While they participate fully in analysis, generally they are not designed and apart from the limited circumstances detailed below. Compound section can only be designed by the following circumstances. Head code must be set either with the Euro code or BS. Characteristics must be set to beam. Compound section type must be set with either plated beam or plated column. Concrete member molding. Modeling concrete walls. Concrete walls, all overview. Concrete walls can be created over several stories heights. They can start with a finish at any level. Although a single wall is created, this does not prohibit a different thickness from being defined in each panel, in which case the panels will be set back one or both faces, depending on the alignment that has been specified. Creation of the continuous way, in this way, as opposed to defining a new wall at each story, does have any significance to analysis of design purpose, but is ultimately important for detailing purposes. The point you have to place concrete wall to define the exact side of the position of the walls. Analysts know that the alignment of the extension property to have no effect on the smile. Either they find FE mesh or mid-pier wall analysis can be adapted on a wall-by-wall basis, provided automatic generated support is selected. No slab or other members exist beneath the wall. When it is first created, support is automatically placed underneath it. Mesh walls default with the model's mesh parameters, but they are overridden to all user-defined mesh applied with the individual wall. Minor access release can be applied with the top of the bottom of each of the panel pin connections. Income slab members are to be modeled in this way. If you want to create a door or window openings in the wall, you must be defined as the mesh wall. It must be defined as the mesh wall openings cannot be catered with mid-pier walls. Both mesh and mid-pier concrete walls introduce structural strength stiffness as your model, but they do not perform same functions as wall panel. They do not act as medium via loads calculated with the wind wizard getting applied with the structure. Therefore, in order for the wind loads to be applied, you should create additional wall panels in same physical locations creating as the concrete walls. However, specify whether the walls to be meshed or mid-pier. You initially chose from whether the mesh or mid-pier model is to be adopted, making the appropriate selection of the concrete wall drop list model toolbar. Subsequently, you can change model type of the existing wall by changing wall type properties and wall properties. How do I create a concrete wall in 2D view? Ensure that you have defined the construction levels between which wall will run and the grid points between which it will lie. Click model concrete wall drop list. Click the model type mesh or mid-pier. The wall adopts property for the concrete wall property set and displayed in the property windows. Check the base level, the top level, and the property set are correct, and adjust the necessary. Check for the thickness for the other properties on the property set are also correct, and adjust if necessary. Click where the wall is started at point 1. If you're using a point along the wall member, then click the member first to see if the points, and click the point where you want to use and type the distance of the point of the start of the member. Click where the wall is end point 2. How do you want to create the concrete wall in the frame structural view? In order to define the wall and frame structural view, must have already defined construction levels between which the wall will run and grid points between which it will lie. To create the wall, Click Model Concrete Wall drop-down list. Click the model type of the mesh or mid-pier wall. Adopt the property for the concrete wall property set displayed in the property window. Check the base level, the top level shown in the property set are correct and adjust as necessary. Check if the thickness of the other property set with the property set are also correct and adjust again adjust as necessary. Click the point where the base of the wall is to start. Click the point where the base of the wall is to end. Click the point where the top of the wall is to start. Click the point where the top of the wall is to end. Tekla structural design creates a wall between these 4 points. How do I specify extensions? You automatically trim the new wall back to the face existing columns or walls. Selecting automatic extension checkbox property windows from creating the wall. When creating the wall, or manually trim and extend the existing wall. Select the wall to be trimmed and extended. Specify the required N1 extension, N2 extension properties window. Positive extension extends the wall length beyond its insertion point, and negative extension trims the wall back from the insertion point. How to specify the release? Select the wall to be released. The property windows of the release properties. Select the appropriate release for the minor. Top of the minor bottom drop list is required fixed pin, continuous incoming members pin, only available to FE mesh walls. Specify pin connection, supported slab use of the FE mesh wall that sends continuous incoming members pin rather than pin. This means pinned option also releases the wall panel above the wall from the wall panel below, which may result in the mechanism during an analysis. Automatic support generation. Automatic generated support checkbox wall properties is used to control whether the support is automatically created as wall base level as follows. Alright, when automatic generator support is on, the generator support cannot be turned off. If there are members slab underneath the wall capable of providing support, no support is generated. If there are no member slab underneath the wall capable of providing support, a support is generated. Automatic generated support is off. Generator support. If the generator generate support is on, a support is generated. If the generator support is off, no support is generated. When a support is required, a line support is formed under the mesh wall with a point of support under the mid-pier wall of the sphere of the point of support under a bearing wall. When a support is required, the degrees of freedom are specified in the wall support area of the wall properties. How do I edit the wall support? Supports can only be edited to leave both in mid-pier and mesh concrete walls via the wall properties. To edit the wall support fixture, fixity, expand wall support in the wall properties, specify the degrees of freedom as required. Because discrete supports at each node angle that the global axis system allows, always not aligned with the wall major and minor axes, is necessary to set both the MX and MY as free as to ensure that the angled wall is pinned out of the plane. It's not strictly necessary if the wall is aligned global X or Y. You could just see the MX and the MY free as appropriate. Similar MX and MY should be set with a fix in order to ensure that the angled walls are fixed out of plane. To remove the wall support, uncheck generator support wall property. Generator support property will available, but editing of the automatic generator support property is inactive. The automatic generator support is on. Generator support will be automatically cleared if the members created underneath the wall to support. Similarly, it will be automatically rechecked if the members are deleted. How do I create a door with a window opening an existing concrete wall? Openings are only active in mesh, not mid-pier concrete walls. Opening a frame view of the frame containing the mesh concrete wall when with which you want to create an opening. Click Model Wall Opening. Either click with the outlined existing wall panel to define the opening relative to the bottom left corner of the wall, and then click the special node's existing wall panel to define the opening relative to the selected node. 3. Pick the first corner of the opening. Press F2 if required. Enter the exact position. Drag the diametrically opposite corner of the opening. You'll see a rubber rectangle on the screen which follow the mouse movement that helps you check the area in which you are creating the opening. 5. Click define the opposite corner of the opening. Again, press S2 required to enter the exact position. Alright, modeling concrete columns. Concrete column overview. Single concrete column can be created only over several stories high. Stacks can start with finish at any level. The different column sections can be defined in each stack. Columns are not restricted to be collinear between stacks. The creation of continuous concrete columns in this way, and opposed to defining a new column each story, does not have to be any significant analysis with a design purpose, but is ultimately important with detail printing purposes. Physical location of the column is determined by the alignment snap points and the offset specified by the column property of the insertion points picks. How do I specify the column shape and size? The model of the concrete column. Click model concrete column. The properties window section box. The default shape and size. Select in the section box. Click new and edit. Select the shape and enter side of the dialog box. Click OK. Click add it. And let you create a hollow column. See how to create hollow columns. How to create a single column. Create column in a 2D view. Ensure that you define construction levels between the column will run in grid points between in which they will lie. Click model. Create column. Check base level. The top level and the property windows are corrected and just necessary. Check the bottom column section that's corrected just as necessary. Check other concrete column property set values are also corrected just if necessary. Click the point where the column is to be placed. How to create a series of concrete columns in 2D view. Ensure that you have the define what the construction level between the column will run. Grid points between which it will lie. Then click the model concrete column. Check for the base level, the top level, the property windows are corrected just as necessary. Check for the column section is corrected just if necessary. Check for the other concrete column property set values are also corrected just if necessary. Move the cursor one corner. Measuring box will encompass for the grid intersection points at which you want to create the column. Click and hold the left mouse button. Drag diametrically opposite corner of the box. See a rubber rectangular on the screen which follow with your mouse move to help you check for the area in which you are creating. Once the rubber rectangular encompass for the grid intersection points at which you want to create the columns, release the mouse button. Alright, how do I create a single concrete column in a frame or structure view? In order to define the column in a frame or structure view, you have already redefined the construction level between the column running and grid points between which it will lie. To create a column, click model, create column, click the column section, correct it just as necessary. Check the other concrete column properties or set values are also corrected just if necessary. Click the point where your column is to start. Click the point where the column is to end. Tactile structural design creates the column between these 2 points. How do I align column to specific angle grid line? The options are provided specifying alignment of the new column achieved by the rotation property as follows: 0, 90, 190. Aligns the column in global axis angle. Aligns the column to the exact rotation angle you specify to define. Aligns the column to angle to any grid line you select. How do I specify the column alignment relative to the grid? How each of the columns is initially placed relative to the grid depends on the automatic alignment setting of the concrete column property set. If the automatic alignment is on, column parameter of the grid aligned with the face flush of the perimeter. Internal columns aligned centrally on the grid. Okay, it shows the properties. Automatic alignment. If automatic alignment is off, columns are aligned to the major minor alignment setting in the concrete and with the column property set. Shows minor alignment, max minor alignment, left, center, right. How to create a hollow column? Click model concrete column in the property selection window section box. Show the default shape and size section with a new edit. With select the shape of the enter side of the dialog. Same dialog. Click add. Tabular part of the dialog. Shape of the dimensions of the void. Leave the minor major offset of the 0 position void centrally in the column order just necessary to create an offset. How do I create an incline column? An incline column can be created with a frame or structural view. In order to define the column, you must define the construction level between which the column will run, grid points between which it will lie. Click model concrete column. Column will adopt properties currently displayed on the concrete column property set. Check the properties shown on the property set are corrected and just if necessary. Click the point where the column is to start. 5. Click the point where the column is to end. Tekla structural design creates the column between the 2 points. Related topics: how do I create a crank column? How do I create a crank column? A crank column can only be created with the frame or structural view. In order to define the column, you must define the construction level between which the column will run, grid points which will lie. Click model concrete column. Column will adopt properties of the currently displayed concrete column property set. Check for the properties shown on the property set are correct and just as necessary. Click the point where the column is to start. Press and hold the control key keyboard. Click the next node of the crank column. 6. Repeat step 3 with the defined pen ultimated node of the crank column. Release the control key. Click the point where the column is to end. How to modify the position of the single column stack. Column stack position can be modified with either the frame or structural view. Seeing content, ensure the grid construction line is checked with the select of the column for which the stack is to move. The column is highlighted in one color. Column end nodes and middle node is in another. Select one end of the nodes of the column stack to move. Ensure the node is highlighted. Select the entity tooltip when selecting opposed to one of the members connecting to the node. Check click a grid construction point, redefine on the column stack and node position. Entire column is redrawn. Select the node, move to the new position. Select the next end node. Enter of the node is highlighted. Selected any tooltip, selecting one of the as opposed to one of the members connecting it to the node. Click the grid construction point to redefine the end node position. Column is redrawn once more, and selected node move to the new position. How do I modify position of the entire column? Select unspecified. Simply use the move command located with the edit ribbon. How do I edit the column alignment or specify an offset? When columns have been placed in their alignment can be adjusted for their offset specified required. A single column alignment can be adjusted with the property dialog box and the property windows. Multiple columns only be realigned with the property windows. Example below illustrates the edit alignment of the property windows. Select the column to be offset. Ensure the column properties are displayed in property windows. Use the drop list over the top of the window if necessary. So we went to properties. We now went to major and the offsets and alignment. Edit major offset and minor offset required to move the columns relative to the major and minor snap level of the mount specified. Minor offsets. Model concrete beams. Concrete beams overview. Concrete beams consist of one or more beam spans. Although single beams are created, but it does not prohibit the different beam section with it being defined in each span. Physical location being determined alignment snapping points, often specified by the beam properties insertion points picked. However, to specify the beam size, click model concrete beam property window section box, show the default shape and size. In section box, click new and edit, select shape of the entire side with the dialog, click OK to save. How to create a single span concrete beam, click model concrete beam in property window section box, show the correct side of the adjust if necessary. Check the other concrete beam properties so that the values are correct, adjust if necessary. 4, click where the beam is to start point 1. If you're using a point along a member, then click the member first to say it's one with either click point whether we want to use the type of the distance of the point to start with the member. 5, click where the beam is to end point 2. If you're prompted with to pick another point 3 will do with the continuous being select with the beam property set. In order to create a single span beam, simply click once again point 2 and press enter key. Alright, how do I create a continuous concrete beam? Click model and concrete beam in the property window section box, show for the correct size, adjust if necessary. Check that the other concrete beam set values are also correct, adjust if necessary. Click with where the beam is to start. If you're using a point along a member, click with the member first to see with the point either. Click with the point where you want to use the type of the distance of the point with start with the member. Click next over the continuous beam. 6, repeat steps 4 until the defined pen ultimated node continuous beam. 7, click the beam is to end. You're now prompted to pick another point. Specify. Click once again on the same point. Press enter key to create the continuous beam. You cannot define continuous beams which are curved either horizontally or vertically. How do I create a series of concrete beams? In order to create beams of the method of floor construction level must already be contained in the columns between the beams that will run. You must also use the 2D view of the floor construction level to use this option. Click model concrete beam. Check that the section on the property window show the correct size and adjust if necessary. To create the continuous beams between the supports, check the continuous box. And create a series of single span beams between the supports. Click the continuous clear the continuous box. Review the other concrete beam property set values, adjust as necessary. Move the cursor one corner imaginary box which encompasses the columns between which you want to create beams. Click and hold the left mouse button. Drag diametrically opposite corner of the box. You'll see the rubber rectangle on the screen. Follow the mouse move with it help you check the area within which you are creating. Once the rubber rectangular encompasses the columns between you which wants the beams creating, release the mouse button. Rebeams are created between each adjacent pair of the columns within the area are select. How do I create a curved concrete beam? Click model concrete beam. The beam will adjust adopt to the properties displayed on the concrete beam property set. Ensure linearity is set with the curve major if you have the curve vertically and the curve minor if your curve is horizontally. Appropriately chord height and the maximum facet error views have been specified to define the curve. You can control the direction horizontally curved beams curve when you place the beam. Select the start point and end point. The beams always curve so that if you're looking at the theoretical line from the start point to the end point, then curve of the beam will always lie to the right of that line. The vertical curve beam's negative chord height value can be used to reverse the curve direction. Just any other details on the property set is necessary. 4. Click where the beam is to start in point 1. If you're using the point along a member, click with the member first to see with the point. Click anywhere the point U the type of the distance point with the start of the member. 5. Click where the beam is to end point 2. Where defining the points of the curve vertically of the 2 view with the floor construction level, the vertical projection beam is out of the plane of the floor construction level that are using. In this case, you will not see the beam graphical display. You will need to change the 3D view to floor construction level of the entire structure in order to see them. Horizontally curved beams always take the chord height defined in the property set, but they do not curve automatically to fit any curved grid line you may have defined. How to specify beam alignment relative to the grid? For initial placement, beams are aligned relative to the grid depending on the automatic alignment setting of the concrete beam property set. If automatic alignment is on when placed the boxing around columns, each beam's alignment follows over the columns between its spans. Because the edge columns were aligned flush with the grid when the beams are placed, the boxing around the columns, the automatic alignment on there are flush also. Okay, it shows your automatic alignment is checked. However, each edge of the aligned centrally where the beams are placed for the automatic alignment, they would be central also. This is never automatic alignment. Alright, if automatic alignment is off, the beams are aligned according to major and minor alignment setting in the concrete beams property set. So we're in the concrete beam property set, minor and major alignment, top or left, right or bottom. How to specify beam flange existing beams. However, the cursor over the beam is to be edited will become highlighted. Right-click, select Edit from the drop-down menu of the concrete beam property dialog box is displayed. Open the design control page of the dialog. Particular spans like consider the flanges. Further box are open to displaying flange dimension initially at 0. Specify the flange dimension. Calculate flange. Flange dimensions are automatically calculated. If required, you can add allowance opening to reduce the calculated widths by the specified amount. 6. Repeat if the additional spans of the beams is required. Once flanges are specified, this will be considered the concrete beam design calculation. However, the flange beam properties are not by default used in analysis. Use flange beam properties in the analysis additional to the design calculation. Select include flange in analysis. Repeat the additional spans of the beams as required. How do I specify use of the beam flange of multiple beams simultaneously? Select the beams to be edited. Edit concrete beam property set shared by the beams are displayed in the property windows located under all spans of design control. Consider flanges. Further box are open to displaying flange dimension initially at 0. Specify the flange dimension for firstly select calculate flanges so that it becomes highlighted. Calculate flanges, calculate, then calculate then click calculate flanges. Bottom flange dimensions are automatically calculated. Only flange dimensions which are common in selected beams can be shown in fields. The different flange dimensions have been calculated for selected beams, and for a field all are left in blank. If you're required to add allowance for the opening, reduce the calculated width by a specified amount. Open flanges have specified in a way that they consider the concrete beam with the design calculation. However, the flange beam properties are not default used in analysis. Alright, to use flange beam properties in analysis, addition to design calculation located under all spans design control, include flanges in analysis. How do I edit the beam alignment, specify an offset? Once beams have been placed in their alignments can be adjusted further offset, specify that is required. A single beam's alignment can be adjusted either the property dialog box or in the property window. Multiple beams can only be realigned using property windows. This example below illustrates editing and alignment in the property windows. Select the beams to edit and ensure the beam properties are displayed in property windows. Use the drop list at the top of the window if necessary. Edit major and minor snap level that is required to realign the beams from the vertical horizontal plane, respectively. Edit minor offset for the move of the beams horizontal relative to the minor snap level of the amount specified. Alright, edit the major offset of the move of the beam vertical relative to the major snap level of the amount specified. How do we modify the position of the beam? Can modify the individual beam's position in 2D or 3D view. Select the beam to be moved. If the beam is highlighted in one color, the beam of the node is in the middle, and the node is another. Now select the beam and node to be moved. Either ensure that the node is highlighted, selected any of the tooltip, selecting the opposed one of the members connecting the node. Click grid construction point to redefine the beam in a node position. The beam is redrawn, spanning the new end position. Slab molding.